Prakash, working as assistant professor in the Department of Mechanical Engineering, SNS College of Technology. In the lecture series, steam power cycles, we have discussed about the ideal Rankine cycles, we have discussed about the Rankine cycle with the reheat cycle, and now today we are going to discuss about the Rankine with regenerative cycle. Okay. Now let's go to the topic. Okay. So before going to the topic, let's have a small recall about what is Rankine cycle. So what is the common principle behind the Rankine cycle is heat is supplied and then work is extracted in the turbine. So the input given is heat and the output is the work done. So this is obtained with the help of a boiler, turbine and a condenser on the pump. So this is the Rankine cycle. So in regenerative cycle we are going to see how the modification is taking place from the Rankine cycle. Okay. So in our design thinking, the first stage is empathy. We are already existing, we are using Rankine cycle. What is the need to switch over for regenerative cycle? So there should be some existing problems, so that why we are going for another solution for another cycle. Like this, what is the empathy behind this Rankine cycle? So here in the Rankine cycle we are using here it is the heat loss has to be reduced in the condenser, and then we have to save the fuel consumptions, and then cost effective is more in the Rankine cycle, and then in the Rankine cycle the pollution is more. So these are all the existing empathy in the existing Rankine cycle. How to overcome this? Okay. So as in the DT, these are the empathize. We are going to define a problem. So what the defined a problem is, we are going to increase the thermal efficiency. So that we are defining with a regenerative cycle. Okay. So here in the regenerative cycle, what happens here is, so this is a boiler. Okay. Here we are having a pump. So here fluid water heat recovery. Here we are using an heat recovery systems, and here there is a turbine and then a condenser. Okay. So here heat is extracted and then the water is getting heated. That is the main concept of the regenerative cycle. Okay. So now let us see how the process is taking place, okay, in detail. So here what happens is, so as we discussed, there are two pumps here. Okay. So this is the feed water heater. Okay. Here the feed water is going into the boiler. In the normal Rankine cycle, this water is not heated. Only the heating takes place in the boiler. But in the regenerative cycle, what happens is, the condensate from the condenser is going to the pump 1. It is pumped to the feed water heater. Here, the steam which is taken in the turbine is used to heat the feed water. So the feed water is getting heated. Again, it is pumped to the boiler. So what is the purpose of this feed water heater is? So the heat which is used to convert the water into steam in the boiler, it is reduced. So it automatically saves the fuel cost and then usage of the fuel. So as the reduced fuel cost and the usage of fuel is reduced, normally pollution is reduced. So here the turbine which is going outside, the heat which is the steam which is going with the waste heat is used to heat the feed water heater. So the working principle is same as the Rankine cycle, but what is the small modification is this feed water is used. Okay. So some heat is taken and used to heat the feed water. So the water is preheated in the feed water heater before going to the boiler. So this is the defining part of our regenerative Rankine cycle. Now these are some assessments. So you can have these assessment questions and you can post your comments, your answers in the comments. Okay. Okay. Now let us see what are the process involved in this. So as the design thinking stages, we have defined a problem. Okay. So how this had to be ideated. Okay. So here there are 4 major processes. Okay. So here isentropic expansion, isentropic compression, and then constant pressure process. Okay. There are constant pressure process, isentropic process. So coming to the 1 to 2. Here if you take here, this is taken as the turbine. Here this is a turbine. Okay. So in 1 to 2, isentropic expansion takes place. Okay. And then 3 to 4, here 3 to 4 heat is rejected. So it takes place in the condenser. This takes place at constant pressure. Next 4 to 5, here this is 4 to 5, and then 6 to 7, here these are pumps. So isentropic expansion takes place in both the pumps. And 7 to 1, what happens is heat addition takes place. So how this working takes place is, this high pressure and high temperature turbine passes through this turbine. So the heat is expansion takes place, and then heat is extracted in the turbine. So here the steam which is extracted is called as the bleed steam. Okay. So this bleed steam, what happens is taken and used for the waste heat recovery system, as the fluidized water heater heats the fluid. Okay. So thus the feed water which is supplied to the boiler is getting heated with the help of this blood stream. Okay. So what is the benefits of the regenerative cycles? Is this what the idea which is made is really solving our empathy? So here 1% of the fuel consumption is saved for every 9-degree temperature of temperature rise of the feed water. So with the waste heat we are increasing the temperature so that the fuel consumption is reduced. So normally it directly affects the pollution. Okay. So the overall thermal efficiency, fuel consumption reduced. So when the fuel consumption reduced, what happens is the fuel cost has been reduced. It not only reflects in our profit and indirectly helps to reduce the CO2 emissions. And then as the water is getting heated, the corrosion of the turbine blades will not take place. Okay. So it increases turbine life. These are some of the things. And we can calculate the turbine work, compressor work, heat input and thermal efficiency based on the enthalpy in the various stages. Okay. And some advantages are, the primary fuel which are used is we are using coal. So this fuel cost is reduced. Okay. And then the fuel efficiency is increased. And emission is the today major. We have to support we have to extend our support to our environment. So by using the regenerative cycle, this CO2 emissions is reduced. And as we told that the heat loss of the condenser is reduced because by using the bleed steam, we are extracting the heat and we are using for feed water heaters. So the overall thermal efficiency is increased and then corrosion is also reduced. Okay. So what is the disadvantages? So some initial cost is more for getting feed water heaters, and maintenance is the major disadvantages. Okay. Now let us summarize. Okay. So in the Rankine cycle, what we have discussed is we have discussed about the introduction of the Rankine cycle, and we have discussed about the Rankine regenerative cycle, and we have discussed about the working principle, and then what are the process involved, benefits, advantages, disadvantages, and how we are going to calculate the thermal efficiency work done with the help of enthalpy, and then all the components and the concepts. So these are some of the references. You can refer for the additional knowledge. Thank you.